Hi fabulous techies, it's Anna here, ready to dive into a magical world of file system mysteries. Let's first log into a terminal session as a root sudo su. Okay, let's find our directory that holds our files first. Okay, so let's head to this directory. lsli command lists the files in a directory along with their inode numbers and any other detailed information such as permissions, numbers of links, owner group, size, and notification date. This information is particularly useful for us because we want to identify the inodes associated with each file that we created for comparing its file metadata. The large numbers on the left side of each file entry is the inode numbers. Each file or directory on a file system is assigned a unique inode number which stores metadata about the file. If you notice, the order of inode numbers is not guaranteed to be sequential or even sorted. The file system manages these numbers based on the internal algorithms and any efficiency consideration. Now let's use the stat command for pink and blue files to find information about these files, including its block size and the number of blocks allocated. Let's do that. So we just say stat pink and blue file. Okay. Alright, so it says that the pink file is a regular file. Well, that's a relief. Imagine if it was an irregular file. Who knows what kind of chaos that would unleash. Remember, the file type along with the permissions, size, link, and the block pointer was stored in the inode table. Let's see if other information from the table is listed in here as well. So we see that the size of the file is 16 bytes and it occupies 8 blocks of storage. The file has a block size of 4096 bytes, which is typical for the file system. Our pink file is associated with this inode number right here. The file permissions are set to 664, and this means that it has a read and write permissions for the owner and the group, and only read permissions for others. Okay, if we look at the data for a blue file, we can see that it has different inode number. Blue file also has a slightly larger size because remember we appended some text to it, but unfortunately we couldn't find any information on block numbers. But hey, we are not gonna stop right here. This only means that we need to go dig in a little deeper like a true detectives. We can be a little Columbus. We're off to solve the case of missing block numbers. What we can do is to use debugfs, which is an interactive file system debugger that allows to examine and modify the internal structures like different file systems. For example, extension 2, extension 3, or extension 4. Debugfs can be used for tasks such as retrieving deleted files, inspecting inode details, and exploring low-level file system information that isn't accessible through standard commands. Now we just need to figure out how to activate it. So first, let's check where our root is mounted. Okay, so we can check how it's mounted by using dft command. Okay, let's do that. We can use this command to display also the disk space usage of all file systems along with their types. So we can see that our root is mounted on partition dev sda3. And now we can open the debugfs tool and attach it to this specific partition. So we can do it like this. Alright, I think we're in. This will allow us to interact with the file system on that partition at a low level, and we will be able to examine inodes, blocks, and other file system structures. Now let's head back to the folder we were working on, and let's use the stat command one more time to see if we can locate our block numbers. Hopefully, okay? Okay. Let's do that. Okay. So we just head back to where we were before and use the stat ink.txt. So let's look at the extents number here. We didn't see that before, right? Did you notice that in debugfs mode we see additional information compared to when we use stat command in regular mode? It's almost like debugfs is saying, "Oh, you thought you knew everything. Let me show you how little you actually know." When we use the stat command on a file, the term extents refers to the way the file's data blocks are organized on the disks. Extents are a more efficient way of mapping large files on the disk compared to traditional block mapping. Instead of listing each block individually, an extent records a range of blocks that are contiguous to each other, reducing the amount of metadata needed and improving performance. This is particularly useful for large files, as it minimizes the fragmentation and speeds up the file accesses. If extents are shown, it means that the file is using this modern method for block allocation. Okay, now let's just copy this block number so we can see what's inside, and let's leave the debug mode. What we want to do now is to check if the block number really contains our file. We want to see the proof, right? You don't want to just believe me, huh? Okay. Here is how we can look inside of our blocks. To look inside a very first block, we can use the dd command. So we just say sudo dd if our partition was dev sd83. We put it here, then we put the block size, which is for 4096, and then we set the count equals to 1. Okay, and we can also copy one block, and then we say hex dump -c to display the data in a human readable format along with the hex value that would correspond to ASCII table. But do you remember what our block numbers was? How can we look inside beyond the first block, right? Because we're not really interested in the first block. I don't know what is even in there. What we need to do is just to use the same command that we just did, and we can skip to our block number right here. Okay, so let's add the skip here, and we can insert our block number. All right, check this out. It says hello ping file here on the right side. This means that the computer didn't lie to us, and this particular block indeed contains information associated with our file. Finally, some honesty in this digital age. Now, for a little challenge. As you follow along, try using the commands we covered today to pick inside your own file blocks. Were you able to see the content just like we did? Share your findings in the comments below. All right. Goodbye!